Hi guys, this is another video by Ducklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you are looking for elsewhere. There's a lot of information out there. Be aware that I am not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So, today we are going over lesson 4.2, equivalent ratios. Our first term is equivalent ratios. Equivalent ratios are ratios that are of different forms but have the same value when simplified. So, ratios of different forms but have the same value when simplified. Example, let's say we have 8 to 12, and we have a different form of a ratio, such as 2 to 3. 8 and 12 and 2 to 3 are equivalent ratios. Because if I were to simplify both of these, I would get both 2 to 3. If I simplified this one, it stays the same, 2 to 3. If I simplified this one and divided 8 by 4 and 12 by 4, I would get 2 to 3 as well. So they would look identical, so they would be equivalent. So they're different forms, but when they're simplified, they have the same value. All right, our next term is simplest form. Simplest form means you have a ratio whose terms are whole numbers and have no common factors other than 1. Ratio whose terms are whole numbers and have no common factors other than 1. So back up to here, if I said 8 to 12, do they have common factors? Yes, 4 divides evenly into both. So this is not in simplest form. So I would divide 8 by 4 and get 2, 12 by 4 and get 3. So 2 to 3 would be simplest form. All right. So equivalent ratios show the same comparisons of numbers and quantities. It's kind of just like fractions. So let's look at this process. Emma has 8 red marbles and 12 blue marbles. If I were to write the ratio of red to blue, red to blue, I would have 1, 2, 3, 4, 5, 6, 7, 8, and 12. So red to blue in that order would be 8 to 12. Okay, let's say that Emma decided she wants to group them differently. So Emma groups 2 marbles of the same color into each group. So group of 2, group of 2, group of 2, group of 2. She does the same with the blue. Now, she didn't change the number of marbles, she just regrouped them. So let's find the ratio, not of just red to blue, but ratio of groups of red to groups of blue. So ratio of groups of red to groups of blue. So groups of red to groups of blue. That would be 1, 2, 3, 4 groups of red to 1, 2, 3, 4, 5, 6 groups of blue. So our new ratio is 4 to 6 with the same marbles. They've just been regrouped. Alright, Emma decides, however, that she can regroup them into larger groups. She notices that she can group 4 marbles of the same color into each group. So let's do that. So group of 4, group of 4. She can do the same with the blue. So the ratio of groups of red to groups of blue groups of red to groups of blue is, let's see, 1, 2, 1, 2, 3. So 2 to 3. So you'll notice we have not changed the number of marbles. What have we been doing? We have been regrouping them, and you'll notice the ratio numbers, or the terms in the ratio, the terms 8 and 12, they keep getting smaller and smaller. So Emma is not changing the number of marbles. What is she doing? She's only regrouping them. And this is the same thing that happens when you're simplifying fractions. You are regrouping. Alright, now what would this process look like without a picture? So let's say you started with 8 to 12, and you realize that you can regroup those numbers. Well, what can you divide 8 and 12 by? Well, you could divide by 2, and that's what Emma did at first. She made groups of 2 right here, right? So we're going to divide both 8 and 12 by 2. 8 divided by 2 is 4. 12 divided by 2 is 6. You'll notice that's what we got here when she regrouped them. Then we notice we could regroup them again, right? So what goes into 4 and 6 again? Well, 2. So let's divide 6 by 2, divide 4 by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And that's what Emma ultimately got, 2 to 3. Now remember, like in lesson 4.1, we stated that numbers in, or the terms in your ratios, they do not give you actual numbers or real numbers of things. For example, she does not have 2 red marbles and 3 blue marbles, because we already know she has 8 and 12. These ratios do not give you real information. It's just a comparison. For every 2, she has 3. So for every 2 red marbles, she's got 3 blue. 2 more red marbles, 3 blue. 2 more red, 3 more blue. 2 more red, 3 more blue. 2 more red, 3 more blue. Okay, now this is basically the simplification process right here. Is there a way to do this faster? Absolutely. Divide by the GCF. If Emma had realized that she could have grouped into these large groups originally, she would have been done immediately, and she would have been, well, she could have stopped playing with the marbles. Okay, so let's say she started with her 8 red and 12 blue, and she's like, oh, I can group them into 4. So let's divide by 4 immediately, which is the GCF. 12 divided by 4 is 3. 8 divided by 4 is 2. So we get 2 to 3 immediately. Alright, so what does this all mean right here? The 8 to 12, 4 to 6, and 2 to 3. Well, this means 8 to 12, 4 to 6, and 2 to 3 are equivalent. They're equal. They're the same thing. And 2 to 3 is in simplest form. And just like fractions, your ratios must always be in simplest form. Always and forever. It's never going to change. I doubt any math teacher is going to accept an unsimplified ratio. Okay. Simplifying ratios is just like fractions. So, before we move on, I want you to think, what if I wrote my ratio as a fraction? Because remember, you can write ratios as fractions, so 8 to 12 is the same thing as 8 over 12. If I were to simplify this fraction, I would divide top, or numerator and denominator, by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. Notice, 2 over 3, 2 to 3. That's the same thing. So, basically what I'm saying is, simplifying ratios is just like simplifying fractions. The only difference is ratios are written like this typically, whereas fractions like that. But really, they are the same thing. Alright, let's move on. Our next practice problem, we're going to express 50 to 20 in simplest form by using the GCF, or the greatest common factor. So, first, let's write down our problem. We've got 50 to 20. Now, what is the greatest common factor of 50 and 20? If I already know it, I can start dividing immediately. If I don't know the greatest common factor of 50 and 20, I'm going to need to find that. Let's pretend we don't know what it is. So let's find the GCF of 50 and 20. So we're going to use the ladder method, or prime factorization. Alright, 50 is not prime. I can divide it by 2. Remember, prime factorization, only divide by prime numbers. We're pulling them out. So 50 divided by 2 is 25. 25 is not prime. Let's continue. 2 will not work. 3 will not work. 5 will work. Why did I skip 4? 4 is not prime. 5 will go into 25 5 times. 5 is prime. We stop. Alright, let's do 20. 20 is not prime. What prime number will go in? 2. 2 will go in 10 times. 10 is not prime. 2 will go into 10 5 times. 5 is prime. We stop. Alright, now what do we do with these prime factors? 2, 5, 5, 2, 2, and 5. We ask, what do they have in common? They both have a 2. They both have a 5. They do not have any more 2s or any more 5s in common or anything else. So what do I do with those? I multiply those. 2 times 5 is 10. 10 is the GCF. So what does that mean? I'm going to divide 50 and 20 by 10, and if I do, I will get my simplest form, or my answer, immediately. Guaranteed. Most likely. Alright, so we're going to divide 20 by 10 and 50 by 10. 50 divided by 10 is 5. 20 divided by 10 is 2. What does that mean? That means, because I divided by the GCF, 5 to 2 is my answer, and I don't have any other work to do. And I'm very happy about it. Now, could you divide by other things? Yes, you could have divided by 2. Would you have been finished? No. You'd have then had to divide by 5, because you decided not to divide by the GCF, so you would not be finished. Simplest form means you can't have any other common factor. So 5 and 2, no common factors besides 1. All right, number 3. We're going to express 8 centimeters to 3 meters in simplest form by using the GCF. So first step, let's write our problem. 8 centimeters, 3 meters. Oh, the labels don't match. They do measure the same thing, so they can be compared as a ratio, but until the units match, I can't do a thing. So what do? Well, first, let me write that the units don't match. So we need to change the largest label, not the number. For example, 8 is the largest number, but between centimeters and meters, which one's the largest label? Well, let's see. King Henry died unusually drinking chocolate milk. Oh, sorry, can't see. So kilo, hecto, deca, and this is meter, liter, or gram. Deci, centi, and milli. Okay, so we have centimeters and meters. Centimeters is right there. Meters is right there. Remember, that M is for milli, like millimeter, millimeter, milliliter, or milligram, but this is meters. Okay, so which one's largest? Well, kilo is the largest over here, down to milli, which is the smallest. So if I want to change the largest label between centimeters and meters, meters is the largest. So we're going to change 3 meters to centimeters. Okay, so we write our number. Okay, to go from meters to centimeters. 1, 2 times to the right. So we're going to move our decimal. 1, 2 times to the right. So 3 meters is the same as 300 centimeters. Also, whenever you change one or the other, you want to move the one, or convert the one in which the decimal will move to the right. If the decimal moves to the left, you chose the wrong one. Pick a different one. All right, 8 centimeters is already centimeters, so we're going to keep it. So now we have 8 centimeters to 300 centimeters. They match. We can now simplify. We still have to find the GCF. So if you know the GCF of 8 and 300, go ahead and start dividing. If you don't, find it. All right, let's find it. The GCF of 8 and 300. So 8. 8 is not prime. What prime number will go into it? 2. 4 times. 4 is not prime. What prime number will go in? 2. 2 times. 2 is prime, you stop. All right, next, 300. 300 is not prime. What prime number will go inside of it evenly? 2. 2 will go into 300 150 times. 150 is not prime. I can divide it by 2. 2 will go into 150 75 times. It's like having $1.50, and I say, what's half of $1.50? 75 cents. 75 is not prime. We can divide by not 2, but 3 this time. Think 3/4 makes 75 cents. So 75 divided by 3 is 25. 25 is not prime. 2 will not divide into it evenly. 3 will not. 5 will. 5 times. 5 is prime. We stop. Okay, what do they have in common? They have a 2 in common. They have another 2 in common. They don't have anything else in common. So 2 times 2 is 4. 4 is our GCF. That means if we divide 8 and 300 by the GCF of 4, we'll be done immediately. All right, so let's do it. 300 divided by 4, 8 divided by 4. Let's do 8 first because that's easy. 8 divided by 4 is 2. Colon, don't forget that. And then 300 divided by 4. Don't know that off the top of my head, so let's do some work. 300 divided by 4. 4 goes into 3, 0. 4 goes into 30, 7. 4 times 7 is 28. Subtract and get 2. Bring down 0. 4 goes into 20 5 times. 4 times 5 is 20. Subtract, get 0. All right, so 300 divided by 4 is 75. Because the labels matched, I do not need any more labels in my ratio. So our official simplified answer is 2 to 75. You'll notice that the numbers actually got bigger. So do not just find the GCF of 8 and 3. No, you need to be looking at your labels. So if you try to simplify 8 to 3, you're obviously not reading the directions or your labels. Labels are important, except for in our answer right here, in which we have none. All right, next section. We're going to determine if ratios are equal. So we have 3 to 4 and 6 to 9. So let's write that over here larger. 3 to 4 and 6 to 9. Okay, now, how would you show your work for this? Well, you would simplify both of them and then determine if they're the same. So 3 to 4. Well, 3 and 4 don't have any common factors besides 1. So what work would I show? Well, I would show that 3 to 4 is 3 to 4. It's already simplified. So I write it right there. I'm basically showing that I know it's already simplified. Okay, 6 to 9. Do they have any common factors besides 1? Yes. You can divide by 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. Okay, now I have two numbers side by side comparison, 3 to 4 and 2 to 3. They obviously don't look the same. You know what that means? That means, are they equivalent? No, they're not equivalent. 3 to 4 and 2 to 3 are not the same. So, what work would be required for, any math teacher wanting you to determine if these are equivalent? Basically everything right there. All right, let's do one more. Are 1 to 4 and 12 to 3 equivalent? So first step, simplify both of them. 1 to 4. Do they have any common factors besides 1? No. But I still need to show that I know that it's in simplest form. So I'm going to rewrite it. 12 to 3. Is it in simplest form? No. So I should not have started drawing a down arrow. Done messed up. All right. Do they have common factors? Yes. What will go into 12 and 3? 3. So 12 divided by 3 is 4. 3 divided by 3 is 1. Okay, I have 1 to 4 and 4 to 1. Side by side comparison. Are they the same? Absolutely not. This is 1 first, 4 second. This is 4 first, 1 second. So are they equivalent? Our answer again is no, they don't look the same. So 1 to 4 and 4 to 1 are not the same. Now remember, this is the most typical way to write ratios, but you can write ratios as fractions. So, I do want you all to think, what if I wrote these as fractions? 1 to 4 would be 1 over 4. 4 to 1 would be written as 4 over 1. Are these the same thing? Well, if I have 1/4 of a cookie, I'm not as happy as if I have 4 cookies, because Obviously, someone ate 3/4 of my cookie, either me and I forgot about it, or someone else. And this person has 4. So they are not the same, not equal. So remember, order matters in ratios. Again, this would be the work required to show that they are equivalent. Why? Because according to our definition of equivalent ratios are ratios that are different forms but have the same value when simplified. So in other words, you have to simplify both to determine if they're really equivalent or not. All right, moving on. We're going to use multiplication to find 4 ratios equivalent to 3 to 4. So 4 ratios equal to 3 to 4. So we're going to write 3 to 4 4 times. And we're going to make this super easy. Since we use multiplication, I'm going to multiply by 2, 3, 4, and 5. So let's multiply by 2. 3 times 2 is 6. 4 times 2 is 8. Our first answer is 6 to 8. 6 to 8 is the same thing as 3 to 4. All right, next one. Let's multiply by 3. 3 times 3 is 9. 4 times 3 is 12. This is our second answer. Next one, let's find another equal ratio. All right, let's multiply by 4. 3 times 4 is 12. 4 times 4 is 16. This is our third equivalent ratio. Last one, let's multiply by 5. 3 times 5 is 15, and 4 times 5 is 20. So 15 to 20 is our final and fourth answer. So we've found 4 ratios that are equal to 3 to 4. Now, why would you want to do stuff like this? Well, we're going to explain in this answer down here. Say you have a chef and he uses 18 cups of lentils and 54 cups of tomatoes to make lentil soup. We want to find all whole number ratios equivalent to 18 to 54 using division. And once we finish it, we're going to explain what the use of doing this is. Okay, so our first step, we need to find, in order to use division, we need to find all the numbers that will divide into 18 and 54. So we're going to find the common factors of 18 and 54. That means we need to use T-charts. Okay, 18. 1 goes into 18, 18 times, so first 2 factors. 18 is even, so 2 will go in. 9 times. 8 plus 1 is 9. 9 is divisible by 3, so 3 works. 3 times 6 is 18. 4 will not work. 5 will not work. 6 will work, but 6 is already on the chart, so we're done. Those are the 6 factors of 18. Let's do 54. 1 goes into 54. 54 times. It's even, so 2 will go into 54. Let's see, half of 50 is 25. Half of 4 is 2. 25 plus 2 is 27. Next, 3. Let's see, 5 plus 4 is 9. 9 is divisible by 3, so is 54. What is 54 divided by 3? I have no idea. Let's figure it out. 54 divided by 3. 3 goes into 5 once, which is 3, minus, and I get 2. Bring down 4. 3 will go into 24 8 times, which is 24. All right, so 3 times 18. Okay, next. Will 4 work? No. Will 5 work? No. Will 6 work? Yes, because 2 and 3 work. 6 times 9 is 54. Will 7 work? No. Will 8 work? No. Will 9 work? Yes, it's already on the chart. So, what are the common factors? 1, 2, 3, 6, 9, and 18. So what are we going to do? We're going to write out our ratio, 18 to 54. We're going to divide these numbers by all of the common factors that we just found, except for 1, because dividing it by 1 is just itself. So we're going to divide by 2. We're going to divide by 3, and 6, and 9, and 18. All right. 18 divided by 2, 9. 54 divided by 2, 27. 18 divided by 3, 6. 54 divided by 3, 18. We've already done all of this work. You should not be doing any more long division. Why? Because we already did it over here. 18 divided by 6, 3. 54 divided by 6, 9. 18 divided by 9, 2. 54 divided by 9, 6. 18 divided by 18, 1. 54 divided by 18, 3. All right, we have found 5 equivalent ratios using division. So these are all whole number ratios equivalent to 18 to 54. Okay, now what's the purpose? Why would we want to use division or multiplication to find equivalent ratios? Well, cooking is probably one of the best examples. So let's say 18 to 54 cups of lentils and tomatoes makes his soup. But let's say very few people aren't coming to the restaurant that day. He needs to make his recipe smaller. So what would he do? If he knows how to divide by common factors, let's say he wants to make the smallest recipe possible, he would have to divide by 18 and he would get 1 to 3. What does this 1 to 3 mean? It means 1 cup of lentils and 3 cups of tomatoes. And that's going to make his smallest batch that he can make. Let's say he does have fewer people coming, but he's still going to have quite a few. He only wants to divide by half, perhaps. So that means he would use 9 cups of lentils and 27 cups of tomatoes to make his lentil soup. So think of these as different size of recipes. You might do this at home whenever you're making waffles and you realize, oh, we're really hungry. We want more waffles. So instead of using, this is completely wrong, I'm just coming up with this random, but let's say instead of using 3 eggs and 4 cups of flour, which is completely wrong probably, you might want to double it and you would use 6 eggs and 8 cups of flour. Probably going to be nasty if you do that because I don't remember. It's been a long time since I've made waffles. But that's where you might want to use multiplication, like, to double things, triple things, quadruple things. So the reason we might want to use ratios and multiplication to find larger equal ratios is if you have like food or you're making food and you want to make more for people, or use division if you have fewer people coming and you want to make a smaller recipe of something. All right, our next section. Missing term problems, as I like to call them. We're going to find the missing term in each of the following ratios. So our first one is 4 to 5 and 12 to blank. My strategy that I like to use is I like to stack them on top of each other. So we're going to write 4 to 5 just because I see it first, and below it I'm going to keep the same order, 12 to blank. So 12 under the 4, blank under the 5, just like that. And I'm going to determine where the missing blank is. Right over here, I can go down or I can go to the right. So I would say, do I know how to go from 4 to 5 using multiply or divide? No, I don't. Do I know how to go down from 4 to 12 using multiply or divide? Yes, I do. 4 times 3 is 12. Golden rule in math. What you do to one side, do to the other. 5 times 3 is 15. So 15 is your answer. So that means 4 to 5 is the same thing as 12 to 15. Now, do you have to always go like in this particular direction? No. It depends on which way is easiest. So let's do it again. Another example. We have 42 to 54. And we have 7 to blank. Okay, the answer box is in the same spot, so we're probably going to go in the same direction. So I could go down or right. You have to go in the direction of the answer box. So, do I know how to go from 42 to 54, multiplying or dividing? No, I don't. Do I know how to go from 42 to 7, multiplying or dividing? Yes. 42 divide by 6 is 7. So let's do that to the other side. 54 divide by 6 is 9. So 9 is your answer. Okay, now one thing I want to note. Sometimes it's easier if you simplify first. So, if you find it difficult, try simplifying first. So let's rewrite this problem. 42 to 54 equals 7 to blank. Okay, so we're going to simplify this one first. What will go into 42 and 54? Well, 6 goes into both, right? I think, yes. And just so you know, you don't always have to do the arrows. You could do stuff like that. All right, so 42 divided by 6 is 7. 54 divided by 6 is 9. And we're going to put that one right below. 7 to blank. So now I would say, do I know how to go from 7 to 9 using multiply or divide? No. Do I know how to go down from 7 to 7 multiplying or dividing? Yes. 7 times 1 is 7. You could also do 7 divided by 1. Okay, what you do to one side, do the other. 9 times 1 is 9. Guess what? Either way you look at it, your answer is going to be 9. This way was easier because I didn't actually need to simplify. Sometimes you do, like this last example. Okay, we have 63 to 27. And we have blank. Oh, look, the blank changed spots. All right, to 21. Okay. So I can go left or down. Okay. Do I know how to go from 27 to 63, multiplying or dividing? No. Do I know how to go down from 27 to 21 using multiply or divide? No. Too hard. So, you have to simplify first. Okay, so let's retry that problem again. 63 to 27, blank to 21. Okay, we're going to simplify the first one first. Okay, 63 and 27. What will divide into both? 9, I think. Yes, all right. 63 divided by 9 is 7. 27 divided by 9 is 3. All right, we're going to put that one right below and stack them. We have blank 2, 21. Okay, so 7 to 3, blank to 21. Do I know how to go from 3 to 7 multiplying and dividing? No. Do I know how to go down from 3 to 21 using multiply or divide? Yes. 3 times 7 is 21. So let's do that over here. 7 times 7 is 49. So our answer is 49. So we couldn't do it like this because the numbers were just a little too weird and too large. So we simplified it first and then stacked them on top of each other. And I was able to do it. Keep in mind, notice on all of these examples, we are going down. It might not always be like that. Your numbers can be rearranged. The blanks could be on top. They could be on the right. They could be on the left. Always go in the direction where the answer box is. We have one more example. A school organized a paper recycling competition. The table shows the amount of oil and the amount of water saved by the recycling paper, or saved by recycling paper. So weighted paper, amount of oil saved, and amount of water saved. And notice some spots are blank. Part A. How many gallons of water will be saved if 1 ton of paper is recycled? So how many gallons of water will be saved, this column, if 1 ton of paper is recycled? Okay, we are going to use ratio reasoning. We are not going to use patterns. So, that's for paper, that's for oil, that's for water. We want to figure out this blank right there. So in other words, to do this, we're going to make one of these problems right here, where you have a ratio and another ratio, but with one of them blank. Remember, order matters. So I'm always going to try to get small numbers in my ratio. So I'm going to do, or match them up, I'm going to do paper to water and another paper to water. So paper to water. All right, paper, 1 ton is recycled. Water, I don't know. That's the answer I want to find out, right? So now I need another paper and I need another water, but I have to have numbers this time. So paper, let's do 2. Sorry for the shadows. Water, 14,000. They must line up in the same row. So paper to water, paper to water. Keep your order. Order matters. So paper 1, water blank. Paper 2, water 14,000. So now I have a missing term problem. Just like this. Okay, so notice the answer box is on top or it's on the right. So notice, let me do a different direction besides up and down. So I could go from 2 to 1 and go up, or I could go to the right from 2 to 14,000. So I'd say, how do you go from 2 to 14,000? Well, you'd multiply by 7,000, because 2 times 7,000 is 14,000. So you do the same on the top. 1 times 7,000. What do you get? You get 7,000. By the way, you could go up. 2 divided by 2 is 1. 14,000 divided by 2 is 7,000. Anyways, our answer is 7,000, but it's a word problem and I need a sentence and a label. How many gallons of water will be saved? 7,000 gallons of water will be saved. I'm going to show you real quick the other way. So paper to water, 1 to blank. Paper to water, 2 to 14,000. So again, the answer blank is on the top. So could you go up? Yes. 2 divided by 2 is 1. 14,000 divided by 2 is 7,000. So the arrows don't always go down. It depends on where your answer box is. Go in the direction of the answer box. And ask, how do I multiply or divide to get there? Okay. Oh, I forgot to fill in my chart. 7,000 right there. Okay. Next, use ratio reasoning, not following patterns, to complete the rest of the chart. So I need this box, this box, this box, and this box. And we are not going to say, oh, plus 7,000, plus 7,000, plus 7,000. No, we are practicing equivalent ratios, so we will use ratio reasoning. And the directions say so anyways. All right, so let's try to find this box right there. You notice, if I cover that up, it looks like I have a missing term problem anyways. Or already, I have 1 to 380, 2 to blank. That's the idea. That's what we're trying to make. So notice we're in the paper column and the oil column. So we're going to do paper to oil. 1 to 380. Paper to oil again. 2 to blank. Okay, answer box is on the bottom or on the right. Let's go down because it's easy to go from 1 to 2. 1 times 2 is 2. 380 times 2 is, let's see, 38 times 2 is 60, 68, 69, 70, 71, 72, 73, 74. 74 plus a 0. 740. So that is that box right there. We used ratio reasoning to do it. All right, let's do this box right here. I'm always going to try to use 1. So let's do paper to oil again. So paper to oil again. 1 to 380 again. Paper to oil again, but now I need 4 to blank. So paper to oil, 1 to 380. Paper to oil, 4 to blank. Keep your columns and rows matching. You should always have 3 numbers and a blank. Okay, let's go down again. 1 times 4 is 4. 380 times 4 is, I don't know, so we're going to have to do that. Let's not try to do that in our head. 380 times 4. 4 times 0 is 0. 4 times 8 is 32. 4 times 3 is 12. 13, 14, 15. 1,520. So let's put that in our chart. 1,520. All right, we've got 2 more. Almost done. We need this box. So let's do paper to water, paper to water. So paper to water, 1 to 7,000. Paper to water again, 2 to 14,000. And I done messed up because I didn't need that column. I am not paying attention to directions. Let's fix that. Pretend it never happened. It didn't. See, it's all blank. All right, so let's do that again. Paper to water, 1 to 7,000. I am trying to find that blank, so I have to use 3 to blank. Good grief. 3 to blank. There we go. All right, that looks right. I was like, what? Okay, let's go right. How do I go from 1 to 7,000? Times 7,000. How do I go from 3 to blank? Well, what I did to the top. 3 times 7,000 is 21,000. Because 3 times 7 is 21. Add your 3 zeros. Okay, so 21,000. Last one. Let's do 1 to 7,000, 4 to blank. So 1 to 7,000 and 4 to blank. All right, let's go right again. 1 times 7,000 is 7,000. 4 times 7,000, 4 times 7 is 28. Add 3 zeros, 28,000. Oops, sorry, there you go. All right. I hope this helped with you being able to find equivalent ratios. If it didn't, there's a lot of other information out there. I hope you find what you're looking for. Y'all have a great day.